Alright, I'm on the last set of videos. If you've happened to look at the videos, kudos to Josh Borges for pointing out to me that I screwed up problem 15. I didn't distribute right, so my answer to 15 is wrong, and I didn't even catch it when I did it, but Josh called it, so shout out to Josh, and I will post another video reworking 15. Alright, 35, 36, and 37. Real world rational equations. These are like the ones 117 and 118 and then the PDF that I uploaded for you. Alright, Sarisa and Josie paint houses together. Sarisa can paint a house in 6 days and Josie can paint it in 5 days. How long would it take the two of them together? Do you know what the most popular answer to this problem is? 11. Now think about how goofy that is. If Sarisa can paint it in 6, then it wouldn't take 11 for them to paint it together. But I guarantee you on an SAT, 11 will be a choice and people will pick it. So let's figure out how to do it. We need this formula. Work equals rate times time. We're going to make a chart. Alright. We don't know the time. The time is what we want to know, so we're going to call it T. So Sarisa's going to work T hours and Josie's going to work T hours. Now we got to figure out Sarisa's rate. If she can paint a house in 6 days, then what is her rate per day? If Sarisa can paint one house in 6 days, her rate is 1/6 house per day. Now let's talk about Josie. Josie's fast. She can paint one house in 5 days, so her rate is 1/5 house per day. So how much work does Sarisa do? Work is rate times time. So Sarisa does 1/6 times T, so that means she does T divided by 6. Josie does 1/5 times T, so that means she does T divided by 5. So this is how much of the total job she gets done in T days. This is how much of the total job Josie does in T days. Together, how many houses do they paint? 1. So Sarisa's work plus Josie's work equals 1 house. Put brackets around the whole thing. The common denominator of 6 and 5 is 30. 6 goes into 30 5 times. 5 times T is 5T. 5 goes into 30 6 times. 6 times T is 6T. Now there's your 11. 1 goes into 30 30 times. 30 times 1 is 30. So 11T equals 30. Divide both sides by 11. T equals 30 divided by 11. Let's get a decimal for that. It's going to be repeating. 2.727272. So 2.72 repeating days. Now let's think if that makes sense. Let's think it out logically. Suppose they both could paint it in 5 days. Then if they both could paint it each by themselves in 5 days, then if they worked 2.5 days, Sarisa would paint half of it and Josie would paint half of it, and we would have a whole house. Okay? So if they both worked at the rate of 5 days per house, the answer would be 2.5. But Sarisa is just a little bit slower. She works at a rate of 1/6 of a house. So my answer is a little bit bigger than 2.5. So 2.72 makes logical sense. So your answer could be 2.72 days or 30/11 days. Right? Now since we've done that one, let's do 37 because it's the same, and then we'll go back and pick up Griffin. So Peyton and Sydney have to pick up all the apples in their yard. So they're doing a job. Work equals rate times time. I don't know if y'all have apples in your yard or not, Peyton and Sydney, but if you do. All right, So, working alone, Peyton can do it in 1.7 hours. So his rate is 1 divided by 1.7. Sydney can do it alone in 2.3 hours. So her rate is 1 over 2.3. Now think about this. Just think, if it took him 2 hours, how much would he get done in 1 hour? 1 over 2. If it takes him 3 hours, how much would he get done in 1 hour? 1 over 3. So if it takes him 1.7 hours, how much does he get done in 1 hour? 1 over 1.7. Okay? So that's their rate. Now, how long is what we want to know, so we don't know it. We call it T. So how much work does Peyton do? 1 over 1.7 times T is T over 1.7. How much work does Sydney do? T, not a 2, T over 2.3. How much work do they do together? A whole yard. Okay. I have to find a common denominator. Well, rather than find it, I'm just going to write out here, it's going to have to be 1.7 times 2.3. It's got to have both. 1.7 goes into 1.7 and cancels, so it's 2.3 times T. 2.3 goes into 2.3 and cancels, so it's 1.7 times T. Nothing cancels here, so it's 1 times 1.7 times 2.3. Now I multiply 1.7 times 2.3, and that's 3.91. I add these two together, that's 4. 4t equals 3.91, divide by 4, get the decimal. 3.91 divided by 4 is 0.9775 hours. Now let's think if that makes logical sense. It takes him a little less than 2 hours to do it. It takes her a little more than 2 hours to do it. So if they're working together, it takes them a little less than an hour. If they were both 2, then it would take them exactly 1, but he is less than 2, and she is more than 2, so his less than is enough that it takes them a little less than 1 hour. So it's 0.9775 hours. Okay. Now the last one, Griffin. Griffin isn't working, he's doing distance equals rate times time. Well, he is working. I know cycling is working, Griffin, but all right. So, what are his two columns? With the wind and against the wind. Every time that I say that, I want to sing a Bob Seger song. Running against the wind. So he's cycling with the wind. He's cycling against the wind. Okay. On a particular day, Griffin finds that the wind adds 3 kilometers per hour to his rate when cycling with the wind. So his rate, we're going to call X. That's his rate. We want his rate with no wind, so we're going to call it X. Well, when he goes with the wind, he adds 3 kilometers per hour. Then he subtracts 3 kilometers per hour when he goes against the wind. Okay. Griffin found that he could bike 36 kilometers with the wind in the same time that he could only go at typo, and I think Josh pointed that out to me too, 24 kilometers against the wind. So if y'all mess up this problem, it's because I made a typo. All right, so distance equals rate times time. Now it said he could go the same time, so the two times have to be equal. Okay, so let's figure out what his time is here. Distance equals rate times time. So distance divided by rate equals time. So 36 divided by x plus 3 is his time here. His time here is 24 divided by x minus 3. It said it's the same time. That means those are equal. Put brackets around the whole thing. They are equal to each other. Put the common denominator out here, which is x plus 3, x minus 3. That x plus 3 cancels that x plus 3, and it leaves me with 36 x minus 3. That x minus 3 cancels that x minus 3 and leaves me with 24 x plus 3. Let's FOIL that out. Distribute. And let's rearrange. Lost an x. I am really tired, y'all. So I moved the 24x over, and I moved the 108 over, and I get 12x equals 180, so x equals 15 kilometers per hour. Now I want to think about that. I want to see if that logically makes sense. Okay, so on a normal day, no wind, Griffin's pedaling along at 15 kilometers per hour. The wind starts pushing him 3 kilometers per hour, so that means he goes 18 kilometers per hour. He has to go 36 kilometers. Well, 36 kilometers at 18 kilometers per hour means he goes 2 hours. Now it said his time down here was the same, so let's check it. He's normally going 15, he subtracts 3, so now he's only going 12, but he's got 24 kilometers to go. 24 kilometers at 12 kilometers per hour means he's going 2 hours, and it said he went the same time, so everything works out. His speed, cycling with no wind, would be 15 kilometers per hour. And that concludes problems 35 through 37.